Want a blade with zero weak spots? Scientists grow one crystal at a time. Start with a wax model of the blade. Include the spiral pigtail detail on the model. The wax model is dipped in ceramic slurry and coated. The assembly is dewaxed, removing the wax core. Then it's fired, creating a hollow ceramic mold. Molten nickel-based superalloy is loaded into a vacuum furnace. Then the Bridgman move. The mold is slowly pulled. It is withdrawn from hot to cool gradually. This forces the metal to solidify from the bottom up. Many microscopic crystals start to form inside the melt. They must squeeze through the mold's spiral pigtail. Only one crystal orientation makes it through. The other crystal orientations get filtered out. That survivor becomes the seed for a single crystal. The single crystal grows up the whole blade, eliminating grain boundaries. The trick is obsessive thermal control in the furnace. Exact speed and temperature keep the solidification front stable. The reward, turbine blades that resist creep and fatigue. They survive extreme temperatures, longer-lasting engine parts. That tiny spiral pigtail makes all the difference.